Mark P. Otten back with you.
All right, so this is your multiple regression or regression with two independent variables video for Psych 320. I'm showing you a data set of real data that I collected a few years ago. This is what I like to call the road rage data that I collected. I'm a sports psychologist. I usually do sports studies, but this one I was curious as to what we might find from this data here. Regarding CSUN students and their attitudes toward driving. So we came up with a few hypotheses that might sort of predict your driving behavior. For example, if you're more trait anxious, there's measures of state anxiety, which is like how anxious you are right now, and then there's trait anxiety, which is more like how anxious you are as part of your personality. And so we hypothesized that if one were to score higher on the trait anxiety measure, that is, they walk around daily life and they're just a little bit more anxious than the next person, that will translate to more road rage, more stronger reaction when something goes wrong when you're driving. So generally, when we ran these numbers, we did find some of these hypotheses to be supported. So I'm showing you the real data. This is the variable view in SPSS. This is available on your Canvas website. If you go to the data, and you scroll down, you'll see, whoa, there's a lot of data. We sampled a lot of CSUN students. This is like 1,562. So lots and lots of data. And I'm just going to include all of these variables here for you to play with if you're a nerd and you want to take a look at a real data set with lots of possibilities to it. And you could even run some of your own analyses and report back to me if you're really nerdy. But anyway, I'm going to just run this, use this as a sample for our multiple regression lesson, and declare two independent variables here and one dependent variable. So I'm going to go and start with the dependent variable. We have the the driving anger scale here, and this is a number of items on a scale of 1 to 5. Students were asked, like, to answer 5 if the statement was highly consistent with how they feel, or if it makes them angry, and 1 is not at all angry. So, for example, I'm going to use the parking lot one, anger 8. Someone cuts in and takes the parking spot you have been waiting for. I'm going to use that one because I feel like that has happened to all of us at one time or another if we are drivers, and annoyed us. So again, if somebody answered 5 to this, that means that it annoyed them a lot, or it tends to annoy them a lot when people do this, and 1 means that it doesn't annoy them at all. So that's going to be our driving anger variable for today. And then I'm going to go up to a couple of these trait anxiety measures. The 7th one, for example, whoops, there you go. The 7th one is I am calm, cool, and collected. And then I'm going to use that one. And then I'm also going to use number 9, I worry too much over something that really doesn't matter. Okay, so 7 is supposed to be a good one, I think, and 9 is supposed to be a not so good one. And so we could hypothesize, for example, about both independent variables here. For the first one, we could say if you are calm, cool, and collected in general as a person, then maybe you're less likely to be upset when somebody takes your parking spot. If you are worrying too much about something that really doesn't matter, and that's by your own admission that it really doesn't matter, if you score high on that, then maybe you're more likely to get upset when that person takes your parking spot. So this is interesting research that I enjoyed doing to try to. This is all self-report though, so we didn't actually go and observe anybody cutting in front of you to take your parking spot and things like that. It's all based on what people say about how they feel. So it's a little bit biased, but otherwise I thought it was pretty cool research. So if our two independent variables are the two trait anxiety measures, the first one being the calmness measure, the second one being the worrying measure, our first step in running a multiple regression to predict anger is to conduct a multicollinearity check. That's multicollinearity Inearity. Multicollinearity. Did you get that? You need to rewind that. All right, anyway. It's a fun word to say if you can get it down. But basically it just means that our two independent variables need to not be too highly correlated with each other in order to be able to enter them into a multiple regression. If they're too highly correlated with each other, then they represent too much the same thing. And so we should just pick one and leave the other out, or we should combine them together, or we should do something, and we should not do our multiple regression until we do that thing to address our situation. So what is too high? Well, our two independent variables, if they're higher than 0.90, then that's too high for sure. If they're less than 0.90 and still like a significant correlation, then we should note that, but we can still go ahead and continue with our multiple regression. So I would think that a correlation here would be maybe negative. If you're more calm, cool, and collected, then you worry less. So let's find that out. I'm going to go to Analyze, Correlate, Bivariate. And again, this is a prerequisite analysis for running our regression, which we'll do in a minute. And so I'm going to select 7 and 9. Those are our two variables that we declared of interest. Move them over to the right and click OK. We'll get our correlation output here, which shows us a negative correlation indeed, negative 0.252. So if you're more calm, then you're worrying less, which makes sense. However, this correlation is not of concern in terms of our multiple regression. So I said that a correlation needs to be greater than 0.9, that is, or less than negative 0.9. It needs to be greater than 0.9 in absolute value. And so this one at negative 0.25 is okay. We can proceed with our analysis and go forward. So the next thing we can do then is run the regression and interpret. So I'm going to go back up to Analyze, and we're going to go to Regression and Linear. And we're going to declare 2 independent variables and 1 dependent variable. The 2 IVs are 7 and 9 on the trait anxiety scale. Those go into the independent slot. And then the parking spot item, which is anger 8, someone cuts in and takes the parking spot you have been waiting for. So frustrating. That goes into the dependent variable slot. And let me see if we need to select anything else. No, I think we should be good to go. So I'm going to click OK. And we're going to get our output. So I'm going to go straight to the bottom here. This is the bottom box that allows us to make our regression conclusion. So we have basically 2 hypotheses, right? We have a hypothesis about the first and a hypothesis about the second IV and their respective impact on the DV. And so that's here. The first one, I am calm, cool, and collected. You go across to the right side here. The 0.103 is your p-value. That is greater than 0.05, so we can say that no. If you are calm, cool, and collected, that does not affect significantly how you might react if somebody cuts in and takes your parking spot. The second one, however, does look to be significant. The p-value 0.000, that's in the row that's labeled I worry too much over something that really doesn't matter. That's your second IV. So if you worry too much by your own admission, then you will be more upset, more angry, it appears, if you have your parking spot taken away. So the moral of the story may be to worry less before you get on the road, and if you're not worried as much, then you are going to be less upset in this case. However, if you're calm, cool, and collected, that doesn't actually matter as much. So worry less, but no need to be calm. Maybe the take-home message there. Okay, so we can fill in the regression equation, and when I do that, when we do that, we can also do a little bit further interpretation and confirm the hypotheses again. So the regression equation is your, you need to fill in your B's and your A's. So the equation, and if you're looking at your homework while you're watching this video, the equation should be stated there in multiple regression form. It's y equals b1x1 plus b2x2 plus a. And so the b1 is going to be the b that corresponds, the slope that corresponds to the first independent variable. So in this case, that's negative 0.61 here for calm, cool, and collected. It's under the capital B column and the I am calm, cool, and collected row, 0.061 negative. So that what that tells you is that gives you the B1, or the B that corresponds to the first IV. It's negative, so it implies as you become more calm, you become less upset when someone takes your parking spot. But when we just concluded here, we concluded that the 0.103 was greater than 0.05. Thus, it's not a significant relationship. So the negative 0.061 goes into your regression equation as your B1, but it does not then, it's not associated with a significant result. And so you can put it in the equation, and you should put it in the equation, but ultimately it does not imply that there's a significant relationship between that IV and the dV. Okay, so here's your equation. I've added your equation here to the right side of the screen, so that's the one that I was just mentioning. The B1 then becomes negative 0.061. For the second independent variable, you just go down the row here, or you go down the capital B column for your SPSS output. So capital B, go down to the second IV. This is, I worry too much over something that really doesn't matter. That's your second IV. 0.128 then is the B value, the lowercase b value that corresponds to that IV. So you put 1.128 then in here. And we said that that was significant. The p value associated with that B, the p associated with the b value is 0.000, less than 0.05. And so we did say that there is a significant relationship here. And it's positive, such that as the amount of worries in your life go up, the more upset you will be when somebody cuts you off and takes your parking spot. The last element of this equation here is the A value. So the A value is going to be 4.004. That's going to come from right here. That's the top row under constant. Constant denotes A. And then the capital B column then is going to still be where you want to grab that value. So under capital B and on the row constant, that's where your lowercase a value is, in this case 4.004. And that really isn't interpreted. You don't need to for the purposes of our conclusions here. What you do need to do is include it in the equation, and then include it if you're going to start making some predictions. So for example, let's suppose let's copy this equation down here. Suppose we have a new person, and they're extremely calm and worry-free. So the ideal combination here. So we're going to suppose that they answered a high value here, 4, on the calm, cool, and collected response, and then they're not worried at all. So if they're not worried at all, they're going to say 1 on that one. And so if we plug those numbers in, you can then do a little bit of algebra and predict what that person might score on the Y, and that is how upset they might be when they get cut off on their parking spot. So you can do this. All you need to do then for your homework when you're making predictions is plug in the values that are specified there in the homework in for x1 and x2, and then do the algebra. In this case, you would multiply negative 0.061 times 4, add 0.128 times 1, which is going to be 1.128, and then remember to add the 4.004 at the end. You're going to get a predicted y value for this person. Then you're going to go down and change these x1 and x2 values to the next person, and so on. And you're going to get a set of predictions. And if those predictions are good, then you're going to have a high r squared value, which is the other value that we need to pull here. If you look back over at the SPSS output, you're going to pull r squared here, which is 0.014 in this case. R square without the d. I don't know why they don't put the d in there, but it's r squared 0.014 in this case. And that represents the percent of variance in your dependent variable that is explained by both of your independent variables. So what does that mean? Well, in this case, if this value is high, then that means that how calm and worry-free you are collectively will then tell you a lot about how somebody's going to react when their parking spot is taken. In this case, if you convert this over, so this is a percentage, 0.014 converts to 1.4%, because if you're converting a decimal to a percentage, you have to multiply, or you have to move the decimal point over 2 spots. So 0.014 again becomes 1.4%. That's pretty low, or it sounds pretty low anyway. And what that means is there's a lot of other factors out there in the world that impact your reaction when your parking spot is taken. If you're calm and you're worry-free, in this case we did say that the less you worry, the less upset you're going to be when someone takes your spot. That's still true, but this just tells you that there's also a lot of other things that might matter as far as how your reaction will be. So in terms of the regression equation, a regression equation is a good one if r squared is high. In this case, r squared is low, and so our regression equation is not doing a lot for our ability to predict. It's correct. We did everything correctly, but it's not doing a lot for our ability to predict how you will react when your parking spot is taken away rudely. And then in terms of r squared, you just need to convert the 0.014 to a percentage, 1.4%, and then state it as that is 1.4% of the variance in your dependent variable is explained by your independent variables collectively. Okay, so that is your quick and easy introduction to multiple regression. I didn't cover the math for how these B and A values are calculated. I didn't cover any variations of this. What happens if you have 3 independent variables, for example, instead of 2? And what happens if you have multicollinearity and all these different things that might pop up. But this should get you started, hopefully, with your future career as a multiple regression analyst. Or maybe you're not that nerdy and you just want to get your homework done.